7.5 parts of similar triangles. When two triangles are similar, corresponding altitudes, angle bisectors, and medians are proportional to the corresponding sides. So what are altitudes? Well, if you have a triangle that looks like this, the altitude would be from the vertex to the base, forming a 90-degree angle. So this here would be the altitude. What is an angle bisector? Well, again, if we have a triangle that looks like this, the angle bisector would split the angle into two congruent angles. So it'd be like if that side was congruent to that side, then this line here would be the angle bisector. And then we have the median. What is that all about? That is, if we have a triangle, it looks like that. The line from the vertex down to the base that splits the base into two equal parts. So if that side was congruent to that side, and we had a line like that, right? So this here would be the median. This one here is the angle bisector, and here's the altitude. And when two triangles are similar, each of these is proportional to the corresponding sides. So here we have one example. We're given that the triangles are similar and they have an angle bisector. So we have this situation right here. And here's our angle bisector. It's size 10, and it's splitting the angle at vertex B into two equal angles. And so is this one, right? So this one, the angle bisector is 8. It's splitting the angle at vertex Y into two congruent angles. And so that means that the corresponding sides are proportional to the angle bisectors. So we can create an equation that goes like this: 24 over x is equal to 10 over 8. And then from here, we go ahead and solve by cross multiplying. So that's 160 plus 32. 192 is equal to 10x. Then x is equal to 19.2. Right. All right. And so you could do that with the altitudes, the angle bisectors, and the medians. Right. But it'd have to be two altitudes in two similar triangles. It'd have to be two separate angle bisectors in two similar triangles, and it'd have to be two medians in two similar triangles. Right. You can't have like an altitude and a bisector in two triangles. So we're over here, and we have the triangle angle bisector theorem, and it's an angle bisector in a triangle separates the opposite side into two segments that are proportional to the lengths of the other sides. So you can see here that SU is the angle bisector because it splits the angle at vertex S into two equal angles, or two congruent angles. So what we can say now is we can say RU over TU is equal to RS over TS. Okay, so the angle bisector splits the opposite side into two segments that are proportional to the length of the other sides, right? So not this side here that it's touching, but it's these two other sides. So we're able to say x over 20 is equal to 15 over 30. And then we cross multiply to solve it, so we get 30x is equal to 300. So we get x is equal to 10, and we're done. And so let me see if there's any more instructional material here. Nope. So the rest of these problems are use this theorem and this theorem in order to solve these problems. And so I'll go over these in the next video.